So just consider the three nodes which are in the pathway of this unbalanced to newly added node. Okay, so if I only perform the rotation in these three nodes, then I will get a picture like this. Okay, so after that, what you will do, whatever nodes are added with a particular node, just add them. So see, there is A, which is left child of B. So I'm adding it as a left child of B. Clear? Then there is Z, which is right child of Y. So I'm adding it as right child of Y. Okay. Then there is C, which is left child of C. So already there is one element in left child of B, sorry, the C is left child of X. So there is already B which is left child of X. So you will add it in this position. Why? Why I am adding this into this position? C node is greater than the value of B. That's why I am adding it into this position, because it is binary search tree. Whatever greater than a particular node will be added as right child. But since C is in the left side of X, see, C is still in the left side of X. So after this arrangement, so again, just perform the rotation on the nodes which must be involved in the rotation, then add the extra nodes as it's according to its position. See here, I have to add A, then Z, then C. A is previously left child of B, so I have added it as a left child of B. Z is previously as a right child of Y, so I have added it as a right child of Y. So it is Z. This C is as a left child of X. Now already there is a left child B, so I have added it as a right child because C is greater than B. So now if I calculate the balance factor, 0, 0, 0 for this, 0 for this, -1 for this 0. So again it is balanced. So above this arrow we have to write RR rotation. Okay, so I have completed up to Z. Now the next insertion is D. So where D will be added? See, first I have to compare with our root element. D is smaller than this. Now B, D is greater than B. Now C, D is greater than C. So D will be added as right child of C. So your picture will be like this: X, B, A, C, D, and this side Y, Z. Now again check the balance factors: 0, 0, 0 for this side 0, this side 1, -1 for this side 0, sorry, this side 1, this side 1, 2, so again -1 for this side 0, this side 1, -1 for this side 1, 2, 3, and this side 1, 2, so 3 minus 2, 1. So it is balanced. Next addition, W. So W, U, V, W, X, Y, Z. So W is less than X. W is less than X. So it will come into this side. Then it is greater than B, greater than C, greater than D. So W will be added as right child of D. So your picture will be like this: X, B, A, C, D, W. Then in this side, Y, Z. Now what are the balance factors? So for W, 0, Z, 0, A, 0. All leaf nodes, 0. Now D. This side, left hand side 0, this side 1. So -1. For C, this side, left side 0, this side 1, 2, -2. For this side 1, this side 1, 2, 3. So 1 minus 3, -2. For this side 0, this side 1, -1. For X, this side 1, 2, 3, 4. See, 1, 1, 2, 3, 4. So height is 4 this side. This side 1, 2. So 4 minus 2, it is 2. Now see what happened in this particular situation. There are so many unbalanced nodes. If there is only a single unbalanced node, then it will be easier because you have to balance that particular node. Now, if there are more than one unbalanced node, then what you have to do? Okay, so what you have to do, you have to consider that this is the newly added node. First, you have to check which one is your newly added node. This is my newly added node. Okay, from this newly added node, there are different unbalanced nodes. This one is one unbalanced node, this one another unbalanced node, this one another unbalanced node. So if there are more than one unbalanced node, then only you have to consider the node which is nearest to the newly added node. Due to this newly added node, this picture becomes unbalanced. So you have to consider the nearest one from the newly added node. So which one is nearest to the newly added node? This is the nearest one from the newly added node. So you have to perform the rotation in between this. So now this is your position where you have to perform the rotation. This is your position where you have to perform the rotation. And just check or take care of these three nodes. Don't see the other nodes. So if you perform a simple AVL trip operation for this three nodes construction, then what is the position of newly added node? It is R. So you have to perform a RR rotation, means like this. So first write the RR rotation picture. So D, then this side C, then this side W. Now this is your after the RR rotation of this particular structure. Then just add it with the rest of the tree. So this is added with B in this side having A, X in this side, Y in this side, Z. Now check the balance factor. 0, 0, 0, 0, 0. Then for this one, this side 1, this side 1, 2. So minus 1. For this side 1, 2, 3. See 1, 2, 3. This side 1, 2. So it becomes 1. For this node, this side 0, this side 1. So it is minus 1. So it is balanced. Clear? So what is this? What is the rule in this case? The rule is if there are more than one unbalanced node, then you have to only consider the node which is nearest to the newly added node. If the position of the newly added node from the unbalanced node is more than 2 position, then consider only the first 2 position, not the last 2, the first 2 position. Means you have to avoid the avoid the newly added node. Okay, so these rules you must have to remember whenever you have to perform a complete operation for an AVL tree. So W is done. Now the next one is E. So I have to add E. So I'm adding E. So E is less than X but greater than B. A, B, C, D, E. So greater than D but less than W. So first you have to compare with root. Then you have to follow the left or right. So E smaller than X. Then B. E is greater than B. Then D. E is greater than D. Then W. E is less than W. So E will be added into this position. So your picture becomes like this. X, B, this side Y, this side A, this side D, C, W, E, and in this side Z. Now what are the balance factor? Check again. 0, 0, 0, 0. For this W, This side 1, this side nothing, so 1. For this side 1, this side 2, so minus 1. For this side 1, this side 1, 2, 3. See, 1, 2, 3. So 1 minus 3 minus 2, unbalanced. For this side 0, this side 1, minus 1. For this side 1, 2, 3, 4. This side 1, 2. So 4 minus 2, it is 2. So there are two unbalanced nodes. Again, there are two unbalanced nodes. Which one we have to consider? We have to consider this is the newly added node. From this newly added node, which one is the nearest one? This one is the nearest one. So you have to consider this as our unbalanced node. Now the next thing, we have to check the position of this newly added node with respect to unbalanced node. Now the position is like this, R, then left, but we can only consider first two. So you have to consider only this RR. Okay. So you have to perform the rotation operation. You have to perform the rotation operation only using these three nodes. So you have to take care only these three nodes. Just think that only these three nodes are present, no other nodes are present. Then if you perform a simple RR rotation for these three nodes, your picture becomes like this. D, in this side B will come, and in this side W will come. Okay. After that, just add the rest. So E, we have to take care E. So E is in left child, so I have added E. Then there is C. C is as a left child of left child of D. So now there is B. So C is greater than B, so it will be added into this position. Done. Then there is a A. We have to take care A. A is as a left child of B, so it is added as left child of B. Okay. Then this whole thing, this whole part is added with X. Added with X. Then in this side, Y and Z. Okay. Now check the balance factors. Is it clear how I have added? So I have to take care this node, this node, this node, because only this B, D, W are considered. So these three nodes are added with these three nodes, B, D, W. So I have to take care where I should put them. So E is in left hand child, so I have added it. C is as a left hand child of D, but here is B, so I have added, since C is greater than B, so I have added it as a right child of B. Then there is A, which is as left child, so I have added it. Now the rest, this part, this total array, this part, this subtree is added with X, so I have added it with X. Done. Now I will check the balance factor. 0, 0, 0, 0. Then for this 0, for this D 1, 2, 1, 2, 0. For this W, this side 1, 1. For this X, sorry, first this Y minus 1. For this X, this side 1, 2, 3. 1, 2, 3, 3 levels, and in this side 2 levels, so it is 1. It means now it is balanced. Okay, so I have completed the insertion of E. Now the next is V. So I will insert the next element into this array, and that is the V. So now I am going to add V. So first U, V, W, X. Okay, so V is smaller than X, then greater than D, U, V, W. So V is less than W, but greater than E. Am I clear? Is it clear now? So first compare with X, V is smaller than, then compare with D, V is greater than, then compare with W, V is less than, then compared with E is greater than, so it will be added as right child of E. So your picture will be like this: X, D, B, A, C, W, E, then comes V, and in this side Y, Z. Check the balance factors. 0, 0, 0, 0, 0. What is the balance factor for E? This side 0, this side 1, minus 1. Balance factor of W, this side 2, this side nothing, so 2. Balance factor of D, this side, balance factor of D, and this side 1, 2, this side 1, 2, 3. So it becomes, balance factor becomes, this side 2, this side 1, 2, 3, so minus 1. For X, 1, 2, 3, 4, 1, 2, so 2. For this, minus 1. Okay, so there are again two unbalanced nodes. This is my newly added node. Okay, so from this newly added node, this node is nearest, so this is my unbalanced node. What I have to perform? I have to perform a, so next I have to check the position of newly added node with respect to unbalanced node, and it is LR. So just consider these three nodes. Consider only these three nodes are present. Then if you perform the LR rotation, we have already seen LR rotation means first you have to perform RR rotation on which node? On the newly added node, and then you have to perform the LL on the unbalanced node. Very clear? So first you have to perform RR in this position. It means I will force E into this position, B will come into this position. So your picture becomes like this: W, then V, then E. Then you have to perform the LL rotation into this position. So this will come into forcefully into this position. So after this, it becomes like this: V, this side E, this side W. Perform the rotation operation using these three nodes, and if you perform the rotation operation using this three node, you will get a picture like this. So it will be V in this side E and in this side W. Okay, then this will be added with rest of the tree. So this is added with D, then this side B, A, C, then X, Y, Z. Okay, so now what are the balance factors? 0, 0, 0, 0, 0, 0, 0. For this again 0, 1, 2, 1, 2. So for this 1, 2, 3, 1, 2. So 1. This is minus 1. So again balanced. Okay. Now in the next step, so I think we have completed all the data. So the given data is, yeah, we have completed all the data. Now suppose another node, after this another node, say F is added. So what will happen? If you add another node F in this structure, then what will happen? F. So F is smaller than this, A, B, C, D, E, F. So F is greater than D, smaller than V, B, C, D, E, F, and E, F. So greater than E. So F will be added into this position. Okay. Now, if you add this, then it becomes like this: D, B, A, C, this side V. Now why I am doing another rotation? Because now the picture of this side, if you see this side, it is full binary tree. Na? So if you add any more extra node in this side, it should create a different type of, see, means rotation, and you will see the total change in the picture, total change in the structure of the tree. That's why I am adding another node. Okay, so F will be added, F will be added into this position. Done. Now check the balance factors: 0, 0, 0, 0, 0, 0, 0. What is the balance factor of B? This side 1, 2, this side 1. So 1. What is the balance factor of this D? 1, 2, 1, 2, 3. So minus 1. This one minus 1. For X, 1, 2, 3, 4. This side 1, 2. 1, 2, 3, 4, 1, 2. So it is 2. So which one is your unbalanced node? Sorry, which one is your newly added node? This is your newly added node. Which one is unbalanced? There is only one unbalanced. The unbalanced node is this one. And see, from there, if you want to reach the newly added node, the position is like this. First, you have to go this side, then you have to go this side, then this side, then this side. So the position value is L, R, L, R. But we can only consider first two positions. So these two positions only considered. So you have to perform the rotation using these three nodes. Okay, it means B becomes the newly added node and U is the unbalanced node. So if you perform, if you check it, this is LR rotation. You have to perform two rotations. First LL rotation in this position, then RR rotation. Logic clear? If you perform, first the RR rotation into this position, then the LL rotation into this position. So if you perform the rotation, the structure is this X, D. Again, just consider these three nodes, no other nodes. Consider no other nodes are there, only these three nodes. That's why I am using this double line. I'm using this double line to take care which three nodes should be considered for my rotation. So these three nodes I have to consider. Okay, so this is what is the position LR. First you have to perform RR into this position, then you have to perform LL into this position. If you perform RR into this position, V will come here, V will come here, D will come here. So it becomes X, V, D. Then you have to perform this type of rotation. So it becomes V, this side D, this side X. So after the rotation, your picture becomes like this: V, this side D, this side X. Done. Now you have to check what are the different nodes that you have to add. So see, there is one branch, this one. Better use another color. So there is one branch, this one, which is added as left child of D. So I will add it. B, A, C. Then the next node is V. In V, there is a part, this one added. So V, see? So V's left child is this two branch, but already there is D. So what I will do, I will add this branch as right child of D because this thing is greater than D. Logic clear? So it will be added like this: E, then F. Then I have to check X. See, there is two elements, this one which is added with X. So I will add these two elements, this subtree with Y, with X, like this. So I have performed the rotation operation on the three nodes, and for these three nodes, whatever added with these three nodes, I have to put it in its proper position. So I have to add, so X, D, V. With V, this thing is added. See, added. With D, this thing is added. With X, this thing is added. So I have added. Now in case of V, since there is a left child or left subtree for V, but now a new node is coming at the left position, so I will add this left part as a right part. Similarly, if somehow you see in your example, in another example where there is a right part and that right part means there is a right child of a particular node, and that right child is means after rotation that right child is replaced by another node, then that right part will be added as means I'm telling you like this. Suppose this is x, okay, and there is something in this part, and there is a v, and after rotation v becomes the suppose v becomes the root position, and x is coming into this position, and already there is something in means no sorry this thing, okay. For this case it will create no problem, but what I am
Hello, sir.
trying to tell, that if there is a picture means if there is something which is occupied by another node, then that must be added as right. Since it was in left, now it will be added as right. If there is something which is in right that is replaced by another node, you will add it as a left. So that's thing I'm trying to say. So after this all operations, if we check the balance factor, the balance factors are like this. The balance factors are like this. So for E it is -1,
Hello, sir.
for Y হ্যাঁ বলো,
Sir, x তো
Hello,
-2
W আছে
হচ্ছে।
একটা।
হ্যাঁ
একটা
ডাব্লুটা
W
কোথায়
আছে।
ছিল, ভি এর
V
কোনটা,
এর রাইটার।
ভি এর রাইট, হ্যাঁ এই পেয়ে গেছি, ঠিক আছে। ভি এর রাইটে যেটা ছিল এই যে আমি এইটাই খুঁজছিলাম, ইফ দেয়ার ইজ সামথিং ইন রাইট হ্যান্ড সাইড ডাব্লিউ, দ্যাট মাস্ট বি অ্যাডেড অ্যাজ লেফট। আর ইউ গেটিং? এটাই আমি বলতে চাইছিলাম, এটা আমি খুঁজে পাচ্ছিলাম না। নাও ইট ইজ ক্লিয়ার না? সি again, just check it. So v d x. So for d, this part, so I'm adding this part, b a c, done. For v, see, for v there is a left part and there is a right part, clear? So that left and right already occupied by some elements. So whatever in left of v, that will be added at the right. See, in this position, done. Whatever added is in the right, that will be added in the left, like this. And then for x, y, z. Is it clear now? I think it is clear. So now the balance factor 0 0 0 0 0, then for this w 0, for d 1 2 1 2 0, for e 0 -1, for x this side 1, this side 1 2, so the balance factor is -1. For v this side 1 2 3, this side 1 2 3, so 0. See, the picture is almost moving towards a complete full binary tree. Okay, so the height is almost like log n. So this is your AVL tree. So you have to remember all the rotations and the rules that I have talked about in this example. Rule number 1, that is very important. If more than one unbalanced node, see, these things are not written in your book, so you have to remember these things whenever you are performing any AVL tree operation. If more than one unbalanced nodes, then take, or you can say consider, the nearest one from the newly added node. Clear? This is one rule you have to remember. And rule number 2, if the position of newly added node from unbalanced node is more than 2 positions, then consider only the first 2 positions from unbalanced node. Am I clear? You have to remember these 2 very important things. Otherwise, the 4 different rotations means RR, LL, LR, RL, you have to remember. And another very important thing means in each and every step you have to perform the AVL tree. Don't do it like this, that first tree create the, means from my experience I am telling you that in exam paper students what they do, they first perform the BST, they create the binary search tree for the whole data, then they try to rotate, but it is not that. Why it is not that? Because see, why I have to take care after each step, because I may be, means my data sequence, I have started from data sequence, but I may be stop after this. So up to this, I have to make it balanced. Then I will take care for the next. That's why don't create the whole binary search tree and then try to rotate. Remember, you have to rotate, you have to perform the AVL tree operation or rotation operation. You have to check the balance factor after each and every insertion operation. Okay. Similarly, there is a deletion step also. Means if you delete a particular node. So to do that, if you want to delete a particular node, you may see, uh, suppose your structure is like this. Suppose this is suppose I'm going to delete. So this is, suppose I'm going to delete this node. I have deleted this node. So what will happen if I delete this node? What will be the balance factor? This 2 0 0 0. This one, this side nothing, this side 2. But previously, in previous case, what is the balance factor for this node? This side 1, this side 2, it is -1. But if I delete this node, then it becomes -2. So now it is unbalanced. So you have to rotate. Logic clear? The rotation scheme is same. But when you are deleting, you have to remember another thing, how to delete a particular node. That is very important. We will learn about this, how to delete a particular node or data from a BST. That is another interesting thing. We will discuss about this in the next class. But remember, after this deletion, suppose you have chosen this node and you have deleted this node, and after deletion, if you have to check the balance factor, and if it is not balanced, then you have to again perform the same rotation. But those rotations are named in a different way, R0, R1, like this. But I don't like this R0, R1, because ultimately you have to perform, means you have to make it balanced. Either you have to rotate it clockwise or anti-clockwise. Means ultimately you have to make it balanced. So if you understand this 4 rotations, that is enough. No need to go for R0, R1, because those rotations